All right, so when we're working with equations, we have to work on identifying the constant of proportionality in equations. So two quantities are proportional if the ratios comparing them are equivalent, meaning equal. This ratio is called the constant of proportionality. It's also your unit rate. Remember that those are the same value. Proportional relationships can be represented by an equation in the form of y equals kx, where k is the constant of proportionality. Select each card to learn about the relationship. So in words, what does this say? It says a linear relationship is proportional when the ratio of y to x is a constant k. So what does that look like? Y equals kx, where k does not equal 0. It can't equal 0 because if your constant of proportionality is 0, you have nothing, because 0 times anything is 0. So if I had no balloons to measure how high they were going, I have no equation. So k cannot equal 0. That coefficient cannot be 0. An example, y equals 3x. So we see y, we see our k, or our constant, which is 3, or our coefficient, and then our value of x. And so what the graph looks like here is this lovely line. You see it goes through the origin at 0, 0. So if I plug 0 in for x, 3 times 0 is 0, y equals 0. So let's look at this right here, this point 1, 3. So if I plug in 1 for x, 3 times 1 equals 3. That gives me 3 for my y. I can take any value for x or y and figure out what the other value would be for an ordered pair. So, can you write an equation in the form of y equals kx for a line that does not pass through the origin? Could I, using y equals kx only? I can't. And that is because, we're going to put this up, it says no. Any value of k when multiplied by the x value of 0 will result in a y value of 0. Remember, any 0 times anything is 0. This ordered pair passes through the origin 0, 0 on the graph of any line. So if we were to look at the graph, 0 times 0 is always 0. And so we're going to look at how y and x, we can use these to graph things as well. All right, so example 1. I think I reset all of this. We'll see. Yep. All right, we're going to go back to slide 1. All right, so Olivia bought 6 containers of yogurt for $7.68. The equation y equals 1.28x times x can be used to represent this situation, where y represents the total cost of the yogurt and x represents the number of containers bought. So we're going to work to identify the constant of proportionality, then explain what it represents. So how can we solve this? We've got to do some math. All right, so it says compare the two equations. Y equals kx, where k is the constant of proportionality, and y equals 1.28x. So we're going to go here, oops, and scroll down. So we know y equals kx. I'm writing it spaced out a little bit because now our equation says y equals 1.28x. Well, we see our y's lined up. So 1.28 must be our k because our x's are lined up. What does this 1.28 represent? Well, if we were to go back to our problem and see that she spent $7.68 on 6 containers, if I did 7.68 divided by 6, I'm going to get 1.4, break down by 8, 1.28. So it's the cost per container. So in the equation, the cost of the yogurt, the constant of proportionality, the k is how much one container that costs, or Wow, I couldn't type. Or is our unit rate. All right. Oops, wrong button up here. So the constant of proportionality has the same value as the unit rate. The constant of proportionality means that the cost of each container of yogurt is then what? Well, it's going to be $1.28. So the constant of proportionality is 1 and 28 hundredths, and the unit rate is $1.28 per container. All right, so how much would Olivia pay for 10 yogurts at the same rate? Remember, the constant of proportionality is 1.28. So if I know that she has 10 yogurts where y, oops, it finally jumped. So we have y equals 1.28x, where y is my cost and x is my number of yogurts. Well, so now I have y equals 1.28 times 10. Well, what's the quick thing when I multiply by 10? I move my decimal because it's the whole number 10, not the decimal 10. It's not a tenth. I move my decimal to the right one space. So I should now have y equals 12.8, except for that's not how I write money when I'm looking for cost. So y is going to equal $12.80 for 10 containers. I could also do my 1.28 times 10 like this. Well, I know I don't need to multiply that 0 out. So 1 times 8 is 8, 1 times 2 is 2, 1 times 1 is 1. How many decimal places? 1, 2. So I go 1, 2, 12.80. Either way is correct, but it would cost me $12.80 for 10 containers. And now you have a check that you need to complete. It is assigned in your McGraw-Hill and in your Google Classroom.